At this point we have a minimal CentOS 7 configuration. For the virtual lab, we have to add the additional components to include the resource management client services and other additional packages to support the OpenHPC configuration. First, we need to enable the necessary package repositories for use inside the CH root. We'll continue by copying the local package repositories inside the CH root. We'll set up the CH root in the other tmux shell so we can watch progress. We'll proceed to copy the EPEL repository across. We should expect to see it here. Next, we install a base compute package. This is approximately 45 megabytes. It's useful to watch the size of the image grow, so we can keep tabs on how big our final image will be as we continue to install packages into the CH root. After the compute node base OpenHPC packages are installed, we can continue to include additional components for the OpenHPC compute instance. Amongst those we'll include OpenHPC's Slurm client and kernel drivers. Some of these commands might respond with nothing to do, but that's fine. Just for the sake of completeness, we're going to follow what's described in the OpenHPC recipe. Slurm client. You see our image already is sitting at 1.1 gigs, looking pretty healthy. The kernel drivers will probably add another 100 megs to this image, and OpenHPC Slurm client is about 40 megs. 124 megs. Next, we'll add the network time protocol support into the compute node image. This is one of the commands that I expect to have a response of nothing to do. And as I expected, it's already installed. Next, we have to install the kernel drivers. This will be quite a large installation, probably about 120 megs downloaded. And this is also nothing to do. And finally, the module's user environment, in this case LMOD, which is developed at TAC at the University of Texas, Austin. At this point you can see that our compute image is getting quite big. It's already 1.3 gigs, and we still have to customize the compute image system configuration next. The guide says we can optionally add the Infiniband support, which in this case we're not going to be doing. Although many of the features that are available would likely be employed in your traditional HPC environment, we have a few limitations with the virtual lab, and we will include a subset of the customizations available. Specifically, we're going to install PAM for restricting SSH access to our compute resources. We'll install both monitoring packages that are offered by the OpenHPC guide, namely Nagios core monitoring and Ganglia monitoring. The reason behind this is that they're both fairly straightforward to install, and they're both very useful for visualizing the cluster. We'll install cluster shell and node health check. Before we can continue, we'll need to enable NFS mounting of the home file system for all the compute nodes. So we'll begin by looking at what the NFS mount configurations are on the client nodes. That's what it is initially. So we're going to mount the /home for the compute nodes over NFS and opt OpenHPC pub to the base image over NFS. Watch over here to verify that this command will add the HPC IP address of the SMS host /home, and it will create a /home mount on the compute nodes. We'll do the same for the OpenHPC. I've seen my error. And we'll watch here to see the change. Now on the SMS host, we need to export those directories into the exports file so that they can be made available for NFS. Following these steps over here. Whoops. And we will enable NTP time service on compute nodes and make sure that they identify the master host as the local NTP server. We're now using this command to enable NTP daemon. Whoops, we should probably... We're watching the bottom of ntp.conf because we're going to add our server IP and the server parameter to ntp.conf. Watching it over here. And as we've come to expect, it translates our global variable into the defined IP address from setenv.c, and it appends it to the end of ntp.conf on the client node compute image. Now I mentioned that we are using PAM. PAM is a pluggable authentication module that restricts SSH access to the compute nodes. It will limit the access only for the users that have an active job associated with the node. Again, we'll watch the bottom of the file. This tells PAM that an account is required. And we continue. We're not going to be adding Lustre client in our virtual lab. And in the next morsel, we'll be installing Nagios.